All right, so when doing a problem like this, the first thing I want you guys to understand is, yeah, we had the power to product rule. If you guys remember, you can distribute your powers across the product. You can also distribute your powers across the quotient, meaning division problem. So what that means, basically, when you guys are doing a problem like this, when you're trying to simplify, remember, we simplify by using the order of operations. First thing you always want to do is parentheses. Can you simplify anything within the parentheses?
No.
Well, you could actually, right? You could use your rules of exponents. However, I actually do not like to simplify inside the parentheses first. All right? So even though, yes, that's technically order of operations, that's what they tell you to kind of do. When simplifying exponents, what I prefer to do is always do my exponent first to get rid of all of my exponents. All right? So to do that, I'm going to use my power to product rule as well as my power to quotient rule. So you're going to distribute that 2 to everything in the numerator and everything in the denominator. The negative 2, I'm going to divide to everything. Right? So the power to quotient rule states if you have a division problem, a quotient raised to a power, that power goes to every single term. So therefore, I basically have 3 squared times x squared squared times y to the negative first squared divided by 4 squared x squared y to the 0 squared times 2 to the negative second times x to the negative second divided by x to the 4th negative second y to the negative 4th. OK. Does everybody see what I did? Now, obviously, ladies and gentlemen, once you get practice with these and you go over and over them, you don't need to show all of your work as well as I'm doing. However, I'm just showing you this is steps that I've used to avoid making a lot of the small mistakes that a lot of students do. Now, I'm going to simplify these. So I'm going to use my power rule, which states, again, anytime I have an exponent raised to a power, I multiply. Well, 3 squared is 9. X squared squared is x to the 4th times y to the negative second divided by 16 x squared. That just becomes y to the 0, guys, which is really just 1. Do you guys agree with me?
Agree.
Good. This becomes, I can't do anything right now with that. X to the negative second. This becomes, that's really like 2 to the first. That is x to the negative 8th. And this is y to the 8th. OK? Now, I'm not going to do anything with the negative exponents right now. I'm going to show you guys what I like to do with them. So the third step, before I really have all I've done is I've tried to simplify them. My third step now is to eliminate all of the negative exponents. Again, this is a method that just works well with me. So I like to now eliminate all my negative exponents. Basically, what that means is if they're negative in the numerator, they're going in the denominator. If they're negative in the denominator, they're going in the numerator to be positive. So therefore, this becomes 9x to the 4th divided by 16x squared y squared times y to the 8th over 2 squared, which is, I'll just write it like that, x squared times y to the 8th. Please check my work and make sure you guys agree with what I just did. What?
I just thought that if they both have like an exponent of x, that we would divide them.
You will. We haven't got to that point yet. This is just the way I like to do it. You can do that. Like we could simplify these first. Like I could have simplified x squared divided by x first, right? You could have done that. Yes?
What is it?
Oh, that should be an x to the 8?
Yeah.
Thank you. That's why I said check me, right?
That's 2x, the original problem.
Huh?
Is that 2x, the original? So
Where's 2x? Oh, that's 2x.
yeah, so wouldn't it be 4, negative 4, instead of negative 2?
It's 2 to the, no, it's 2 to the negative second power. So 2 to the negative second power. Again, remember to rewrite that as a positive power, I have to write it in the denominator. Be careful. 2 to the negative second power is not negative 4. 2 to the negative second power is 1 over 2 squared. Right? OK, so now what I can do is I can use my, now what I like to do is I like to use the product rule. All right? And ladies and gentlemen, when using the product rule, basically the best thing we can do is multiply. I like to add rather than subtract. So if I like to use the product rule before using the quotient rule. So x to the 4th times x to the 8th is going to give us x to the, anyone? 12. 8 plus 4 is 12. Divided by, on the denominator, I have x squared times x squared, which is x to the 4th. And y squared times y to the 8th is y to the 10th. Now I can use the quotient property. Well, the only thing I can really, oh, wait, hold on. That's 16, right? Oh, 16 times 4. Where'd 3 come from? 16 times 4. So 2 squared is 4. 4 times 16 is 64, correct? What? Did you follow me from where I got from here to here? All right, so now we got to see if we simplify. Can we simplify? Can we reduce 9 over 64?
Yeah, you can.
The only factors of 9 are 9, 1, and 3. And 9 does not go into 64 because 9 times 7 is 63. And 3 does not go into to 64 because 3 times 21 is 63.
Wow.
Right? So we can't simplify there. So the only thing we can do is to use the quotient rule for x to the 12th over x to the 4th, which is x to the 8th.
So what did you do again? I just got lost that fast.
Well, you can raise your hand at any point, and I'll be more than happy to re-explain a step. What's that?